Okay, this is 5.6, factoring a perfect square trinomial and a difference of squares. So we're going to look at two cases today. One is called a perfect square trinomial. This one has, how many terms does a trinomial have? Three terms, good, 3 terms. And then difference of squares is going to have 2 terms. Okay, we're gonna look at that at the second part of today's lesson. All right, so perfect square trinomial is basically something that has 3 terms. Here we can see 1, 2, 3. And we are trying to understand if we can go from this directly to this. And that's your finished factored product. Okay, now remember, factored, usually what we're trying to get is something like this, right? 2 brackets next to each other. Now that is the same as that. You guys all understand why, right? Like when that's squared, that's the same as that, right? Everyone understands that? Yeah. Okay, so if we can go from this to this, we're done. Okay, we've factored it. Okay, so the whole thing that Con was trying to teach there is he want you guys to check if it's a perfect square trinomial. So that's what we need to do. Whenever we see a trinomial and we see that the last term is a perfect square, now it doesn't have to have a square on it, it just has to be a perfect square number. What is perfect square numbers? Yeah.
A number that you can square root.
Yes. So is 4 a perfect square number?
Yes.
How about 7?
No.
How about 13?
No.
How about 25?
Yes.
How about 36? How about 48?
Yes. No.
48? No. 49?
Yes.
Okay, you have to know this. You have to know. This is from earlier math, right? You got to know that 7 times 7 is 49. You have to know that. You got to know 8 times 8 is 64. You don't know that, you're going to have to check those numbers. If you see a 64 here and you don't know a 64 is a perfect square, you're going to have to use your calculator and do 64 square root. And you're going to find it's perfectly 8. 8 times 8 is 64. Okay, you have to know that to check. If you don't know that, you're dead in the water. You need to know what perfect squares are. So perfect squares are, we're going to go in order here. 1, 4, 9, right? 3 times 3, 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. Right? You gotta know all those. All right? If not, then you have to take that last number and square root it. If it's a perfect square, you'll get an even number. Okay? So example 1. That's the first thing we're checking. Is the first term a perfect square? Is the last term a perfect square? And of course, a squared is just 1a squared and b squared is 1b squared, so these are both perfect squares. Once we decide that the first term and the last term are perfect squares, I'm going to give you guys a big hint here. You're probably in that perfect square trinomial, that perfect square trinomial category, right? They're usually setting you up for that. So if you notice that the first term is a perfect square and the last term is a perfect square, you're likely close. Now the way you check is you just have to take the square root of the first term, the square root of the second term, and times those together times 2. And then you got to check if that's the middle term. That's all you need to do. Okay, so with Con, he said A, B, and all these things, but basically you're checking if that middle term is the square root of this times the square root of this times 2. All right? So what's the square root of x? X squared, sorry. What's the square root of x squared? X. What's the square root of 25? 5. So we have 5x times 2. Is that 10x?
Yes.
Is it? Yes, right? So we know that this is then a perfect square trinomial. That's it. So all of that, what he was trying to explain on Con, that's all you're doing. First term, perfect square, yes. Last term, perfect square, yes. The square root of those 2 terms times 2. Is it the middle term? Yes, you have a perfect square trinomial. Okay? So this is what we're looking for. Here's how we find perfect square. First term, positive. Sorry, it has to be positive. Last term, positive square. Yes. Middle term is twice the square root of the product of the first and the last terms. So basically all of that to say is it 2 times the square root of a squared times the square root of b squared, basically, right? Here it is with an example, x squared plus 10x plus 25. The first term is a perfect square x, the last term is a perfect square 5, and the middle term is 2 times x times 5, which is 10x. So we can go from this to this. And this middle sign here becomes this sign. That's it. That's all you have to remember. That sign, whatever it is, if it's positive or negative, goes right in the middle. That's it. You don't have to remember that 25 is square root of 5, negative 5 times negative 5, or 5 times positive 5, as Con was saying. Just take that sign, put it in the middle. Okay, example 2. Here's example 2. We're going to go through our list. The first term is a positive square. Is it a positive square?
Yes.
Yes, it is. So we got that. The last term is a positive square, perfect square. Is it?
Yeah.
Yes, so we have that. The middle term is twice the square root of the product of the first and last term. So all of that to say, what's the square root of this? 4x. What's the square root of this? 3y. And then we want to see if this times 2 is equal to the middle term. So 4x times 3y is 12xy times 2 is 24xy. So this all works out. So this all becomes, in one step, 4x, 3y, and the middle sign goes there with a square. That's it. So whatever this sign is here goes there. That's it. Any questions? Easier than con?
Yeah.
Way easier, right? Just checking the first and second, and then seeing if they're the sum of the product is the first and last term. All right. Factor and check by expanding. So here we go. We're going to try this one. We're going to go right here. First thing we're going to look. Perfect square? Yes. Perfect square? Yes. Now we need to see if the negative 8 is the sum times 2 of these two. Right? So 16x becomes 4x. And then 1, the square root of 1 is just 1. Okay? And now I need to check. This times this is 4x times 2. Is it 8x? Yes, it is. The whole thing works. What sign am I going to put here? Minus. It's just this sign goes here. And don't forget the square at the top. And that's it. You're done. Super fast, super easy. Now if we want to, it says to check by expanding. So we have to FOIL this, right? That's how we check, by expanding. So we're going to do 16x squared minus 4x is minus 8x, and then plus 1. There we go. Same as the answer. All right, B. Adrian's going to try this one. So 7a plus 2b squared, you're done. But the only thing you need to do is check this, right? This times 2. So you get 14ab times 2 is 28ab. Does it work? 14 times 2 is what? 2. Yeah, 28. So it works, right? Done. See how fast that was? Now it says to expand to check. The check is harder than the actual problem, right? We'll go 49a squared, and then we get plus 7ab plus 14ab. Sorry. You get 14ab plus 14ab plus 4b squared equals 49a squared plus 28b plus 4b squared. All right, Liam, you're going to do this one. We got a problem here. We got a real problem. See what's the problem? Yeah, negative. So what can we do? Got any ideas, Liam? First of all, it's also out of order, right? We like to see the square first. Okay, so I'm going to deal with that first. I'll just put it in the right order. Okay. Anybody confused what I did there from that to that? Don't forget the equal sign. That to that. Anyone confused about that? I just rearranged it, right? All right, now, one of our first checks, right, is the first term positive? It is not, it's negative. So we have to get rid of the negative. What can we do here? Liam, do you know? No? What do you notice about the negative? It's negative, negative, negative. What can I do? Yeah, Liam. Okay, I can't multiply it. You're on the right track, though. That was everyone's idea, Max's? Yeah, but how do I do that? You're right, but you have to do something first, Junior.
Can't you like make the square and the negatives are gonna cancel out or something?
No. Yeah, Adrian? No. Flip it. Yeah, I can divide out -1. Okay, this is a way of factoring, right? What's common between all of these terms is -1. I can take -1 out. And then what I'm left with is I'm dividing each one by -1, -1, -1. I'm left with positive everything. Does that make sense? Do you see how I did that? See, now to go back, if I went back this way, if I multiplied everything by -1, I would get this. So do you guys see how that's the same? Do you understand that?
Yeah.
That negative is on the outside now. So now if I leave that negative on the outside, we're not going to worry about it. We're just going to leave it there. And we're going to check this for perfect square trinomial. And we're going to go to one step and see if we can go from that to that. And Liam's going to finish it off. Okay? So what is the perfect, or the square root of 16d squared? 4d. And then I'm going to make this bigger. And then 9 square rooted? 3. Okay, squared. And what sign do I put here? Positive. Okay, and now we have to check, right? How do we check if this actually works? No, not FOIL. That's to check, you're right, at the very end, but to make sure that this is actually a perfect square trinomial, what do we have to find out about this 24?
So you add both in the square root.
No. Remember, it's the product. What are you going to do with these two terms? Multiply, and then multiply by 2. So 4 times 3 is what? 4d times 3 is what?
20.
12d times 2 is?
24D.
Okay, so does it work?
Yeah.
Yeah. So we're good. And then to check, we would have to do negative. I'm going to leave it on the outside. I'm going to FOIL this. 4d plus 3. 4d plus 3. If negative, leave it on the outside. I do 4 times 4, 16d squared. And then I get plus 12d plus 12d plus 9. And it gives me negative 16d squared plus 24d plus 9. And now I distribute that negative sign to each term, and I get that, which is that. So it worked out. Okay? Any questions there? All right, last one here. Negative 20 x squared. RC, you want to try this one? Okay, now one thing you'll notice, first of all, we don't have a positive first term, right? That's the first thing we check. First term is positive square. It's not positive and it's not a square either. 20 is not a perfect square. So what do you think we can do here, RC, with this? What do you think we can do before we check for a perfect square trinomial? We don't want to try and factor it like this with an x. We're going to get some massive numbers here. Right? Okay. We don't have to rearrange it because we have our x squared first, but what can we do? Can we take out a common value? Can we? You're not sure what to do here? We have to factor out the greatest common value between all three of these terms. You know what that would be? Yeah, Adrian said it there. 5y. Now, you're right, Adrian, it is 5y, but I don't want to do 5y. I want to do minus 5y. Does that make sense? Because I want my first term to be positive. Does that make sense? So what we're going to take out, RC here, is negative 5y. And now I have to divide each term by negative 5y. So what's the first term going to be, RC? Not x, but x squared, yeah. And then plus, or sorry, not plus, negative, right? Because it's 60 divided by negative 5. Yeah, negative 12x. Good. And then negative by a negative is plus, yep. Yep. And y is canceled, so it's just straight 9. So now what I have is my negative 5y on the outside, and this, we're going to check if it's a perfect square trinomial. Let's assume it is, so I'm going to go right to that squared. We're going to double check here first, but the first term, square rooted, RC is 2x. The last term, 9, square rooted, 3, yep. And then what sign do I put here? Yep. Okay, now you're going to check if this 12 works. How do you check? You take the 2 times it by the 3, you get what? 6x, right? And then times 2. 6x times 2 is? 12x, right? Yeah, so it works, right? So there is your answer. Yep.
Would you get the same answer if the negative was multiplied?
If negative,
Instead of on the 5y, it was like on the 4x squared.
here,
Yeah.
you can't do that if the negative is there. Remember, the first thing we check has to be a positive square. See? Has to be a positive square. So it cannot be a perfect square trinomial if there's a negative there. Okay? You can't actually take the square root of a negative number, right? Because no two identical numbers multiplied by each other will give you a negative answer. Any questions? That's perfect square trinomial. Easy? I hope. The next one, believe it or not, is even easier. Believe it or not. This is my favorite one. If you see this, this goes all the way up to calculus in grade 12. You're going to see this very often. It's always one of those questions where you're like, oh, I forgot to check. And you do all this work and you're like, darn, it was a perfect difference of squares. It was a perfect difference of squares and I didn't check. And I did a whole bunch of work and I never checked. Whenever you see a binomial that's just two terms and you need to factor it, the first thing you want to check, are they both perfect squares? Yep.
So it's for the answer for 480, x plus 5, x minus 5.
Yeah, you jump into the answer here? Jane? Yeah, you're right. Okay. Not waiting for me to teach, eh? You're right, that's the answer. And here's the law. When you have one term minus another term and they're both perfect squares, you can go right to a plus b, a minus b. And the reason why this works is because when you multiply this out, right, when you FOIL this, you get a squared, and then you'll get minus ab, and then you get plus ab, and then you get minus b squared. So what you can see here is happening is those middle terms cancel out when you have a difference of squares. All right? So these should be very easy here, I hope. So what's going to be the answer to this one? Andrew?
Wait, which one again?
B, this one.
B. So it's gonna be
So you check. Perfect square? Yes. Perfect square? Yes. So you know you can go to 2. Yeah.
5 x. No, sorry, 5w minus 6, 5w plus 6.
Yep. That's it. Okay, this one down here. Let's go with Teodi. Actually, this one's pretty hard. We'll do that one last. Let's go up here. Teodi.
4a minus 7, 4b plus 7.
Doesn't matter which one you put first, Teodi, the minus 7 or the plus 7. 4k. Does it matter? No, it doesn't matter, right? Because if you have 4 times 5, it's the same as 5 times 4, right? It doesn't matter when you're multiplying the order. Okay? All right, this one, Chenier. It's a little bit harder, but I think you can do it. Okay, you're taking the square root of this.
Can I like flip it? Isn't the square supposed to be like the square root or something like that?
It doesn't, you could, it doesn't matter in this case, but let's, okay. Actually, you can't in this case because we need the difference of squares. So if we flip it, it will be the negative value plus this value. It won't be a difference of squares. So you actually need to keep it like this. So what's the square root of 100? 10. Okay, we're going to do minus or plus, doesn't matter. The square root of x minus 3 squared. What's that? No. It's just x minus 3, right? Because x minus 3 squared, so if you take the square root, you're knocking off the square. So make sure you keep it in brackets. You have to keep it in brackets because of that negative sign. Do you understand why that is the case? The square root of x minus 3 squared is just x minus 3. Does that make sense? Just like if, 8 squared, square root is 8. Right? You're just knocking off the square with the square root. Okay, so now we have 10 minus x minus 3. You need to now do expand. This negative sign belongs to both terms. So it's minus x plus 3. And you have 10 plus x minus 3. So what we get is 10 plus 3, we get 10, sorry, 13 minus x times 7 plus x. That's our final answer. 10 minus 3. Right here. 10 minus 3. Okay? Any questions with that one? A little bit more confusing, but I think it's manageable. Just the same as this one is going to be a little bit confusing, but manageable. It's a difference of squares because they're both perfect squares, right? Whatever's in the bracket square rooted is going to be what's in the bracket, right? Because of that square, we know they're perfect squares. So Josiah, what am I going to get here? Yeah. You just have to take the square root of both of these, right? This square root, this square root, this square root, this square root, and then it's plus and minus, right? So it's this, and the square root of this, 2c plus 1, right? It's not hard. 5c plus 3, and then 2c plus 1. Okay, and then we have a plus here and a minus here. Does that make sense?
Yeah.
And now you have to gather like terms, 5c and 2c, we get 7c, and then 3 plus 1 plus 4. Now this, you have to be careful because of that negative, right? You're going to have 5c minus 2c, so we get 3c, and then we have 3 minus 1 is plus 2. Okay? Last one over here. Max, you want to try this? No, this, Max. Is it a perfect square, Max? 4?
Yeah.
Yeah. Is 9w squared a perfect square?
Yeah.
Yeah. So what's the answer here?
2
Yeah, 2.
minus 3
Yep, minus 3 what?
W.
Yep,
And then 2
yep.
plus
3 what?
3 W.
Yep, done. That's it. Nice. This one says, determine the value of b so that each trinomial is a perfect square. All right. So the way we need to do this is we need to determine the value of b that's going to make the middle term. Yeah. Which one? This one? Plus 2. I got 5c, 3 minus 1. Because that negative goes to, I skipped a step here where I didn't multiply this out. But you see how this is negative 1? 3 minus 1. You got it? Okay. All right. So we got to determine the value of b so that each trinomial is a perfect square. All right. So we have y squared. So the square root of this is just going to be y. The square root of this is going to be x. And we need to get a value that will double to give us 10xy. So really we need this to be 5x, right? If we want to times it by 2 to get 10xy. Does that make sense? We want the b to be a 5, right? But it wouldn't be 5, it would be what? Ethan? Yeah, it would be 25, right? So b would have to be 25. Now, why 25, Ethan, and not 5? Right, you need to square root it, right? So you would have this and this, 5x and then plus y squared. Right? Next one. This one we need now to find the square root of 36. So this is going to be 6x. This is going to be 7y. Right? We want this to be squared. This is going to be negative here. We need to determine the value of b that makes all this work. So it will be 6 times 7 times 2. What's 6 times 7? 42 times 2? B is 84. All right. 6. Determine two values of k so that the trinomial can be factored as a difference of squares. So we just need to find two values that make this a perfect square. That's it, right? So k could be 9 or k could be 16. Anything that makes this a perfect square. That's it. Or 81, or 100, or 36. Okay? Any questions? All right, almost done here. We're gonna now look at a word problem. Find an algebraic expression for the area of the shaded region in factored form. So we want to find the area of this shaded region. Any ideas how we can do that? Yeah.
Find just the shaded square area and then minus the blank square.
Yeah, so find the big square minus the little square, right? So let's say area of shade equals area of big minus the area of little, right? If we take this big area, the whole thing, minus this little area, we're going to get the shaded area. That makes sense?
Yeah.
Okay, so the area of the big, so this is going to be area of the whole, sorry, the shaded is what we want. The area of the big is going to be 3x plus 4, and this is a square. We know this means equals, right? So this side is also 3x plus 4, and this is also x minus 2. So we're doing 3x plus 4 squared. Okay, minus x minus 2 squared. Any questions why I did this? I'm taking this area, this times this, minus this area, this times this. Okay, now we have a difference of squares. Milkius, can you tell me what's next? What do I do here? If I have a difference of squares. If I have a difference of squares, I can go to two brackets. Right? What am I going to put? One is going to be plus. One's going to be minus. What do I put here and here and here and here? Come on. I'm doing this the whole period. You can do this. You got to take the square root of this. What is it? 3x plus 4 squared. What's the square root, Milkius? Yeah, 3x plus 4 plus, what's the square root of this? Yeah. Now I didn't have to put the brackets there because there's no negative, so I could just keep the brackets out. Here there is a negative, so notice how I did put the brackets in. We're going to do the same thing, right? 3x plus 4, and then x minus 2 in the brackets. Now I can gather like terms. 3x plus x, we get 4x, and 4 minus 2 is plus 2. And then on this one we get 3x minus x is 2x. And then we get 4 minus 2 is 4 plus 2 is plus 6. So that's the area of our shaded region.